Students, our next topic is atmospheric pressure of the chapter force and pressure. Now, atmospheric pressure is something which is related to the atmosphere, and you are all already well versed with the atmosphere. What is atmosphere? Atmosphere is the surrounding which is present around us, like water, trees, plants, air, etc. So with all these comprises of atmosphere, and in this atmosphere we live in. Now this atmospheric pressure is based on the air, which exerts pressure on the surrounding. So we can say that atmospheric pressure is based on atmospheric pressure. The concept is based on air. Atmospheric pressure concept is based on the air. We have to study about this. Now we know that air is a matter. Although we cannot see air, but air is matter, because air is a why air is called as matter? Because it is having weight, and all the matter we have already gone through this chapter matter, that matter is anything which is having weight, volume, and can be perceived by our senses, that we can feel it. So because it is matter, so it is having some weight, and because it is having weight, so this is a matter which is called air, and air is exerting some pressure on the earth, which is called atmospheric pressure. So air is a matter, and matter has weight, so air exerts pressure on the earth with its weight. So we can say that what is pressure of air? And we have already studied about pressure, that pressure is anything which is thrust upon area. So for air also it is the same. Thrust per unit area is called pressure, which is for air. Now for atmospheric pressure, we can define it as the thrust on the unit area of the earth surface due to the column of air is called the atmospheric pressure, which is about 10 to the power 5 Newton per meter square. The unit of pressure is Newton per meter square, which is also called Pascal. Student, we have to note two things, that our blood is coming under the category of liquid, so blood is also exerting pressure, which is called the blood pressure. And whenever we go high in altitude means whenever we go in mountainous area, the atmospheric pressure is less on that area. When we go high in the altitude above the earth, that is, we are talking about here we are talking about mountains, so the atmospheric pressure decreases on that area. For example, areas like Jammu and Kashmir, Himalaya, etc. So there the atmospheric pressure is very low, or it is very much decreased. Now to understand atmospheric pressure, we will go through some activity which is given in the book. Now the first activity which is given in the book is, what we have done here is, we have taken a glass which is full of water, and we have covered this glass with a cardboard. You can also cover it with some plastic lid. Now what we have done, we have to press this lid from the top with our hand, and then we have to turn this glass upside down like this given in the picture. Now what you can see, and then after we have to remove our hand from the cardboard. Now what you can see, that it is this glass is having water which is liquid, so liquid is also exerting pressure, and here atmosphere is also exerting pressure. Atmosphere means the air which is outside the glass is also exerting pressure. So this pressure is becoming equal. Pressure exerted by the liquid at the bottom is becoming equal to the pressure exerted by air outside the glass. Both are becoming equal, and so this cardboard is not getting removed from the glass unless and until we apply very high pressure on this cardboard. So this is the example of atmospheric pressure which the air is exerting on this glass, so that this lid is not getting removed. So this was the one example in which air was exerting pressure on the glass from outside. Now they have taken another activity. In activity A, what they have done, you have to take a tin bottle and just remove that lid or top from the bottle and put the bottle with fill the bottle with water, and then after heat this water and remove the top from the tin bottle. What you will see, that this water will start boiling and vapors will start coming out of this tin bottle. In the next activity B, what you have to do, again you have to fill this tin bottle with hot water and you have to cover the tin bottle with the stopper. Now this tin bottle is also hot from outside. Now what you have to do, you have to put this tin bottle in the tumbler or a tub filled with water, half filled with water, and you have to pour cold water on this tin bottle. What you will observe, that this bottle will shrink or collapse. It will change its size. The reason is the water which was the water which was hot from inside condenses into droplets and gets settled down in the bottle, but the area which was outside the tin bottle, which was hot, also get condenses and pressure is high out of the bottle than inside the bottle, and that is why this tin bottle collapses or gets shrinked, because of the high pressure outside the bottle and low pressure inside the bottle. Low pressure is created, or you can say a vacuum is created inside the bottle, and high pressure is being created outside the bottle, and so the reason is this bottle gets shrink. And this, in activity A, the bottle do not get shrink because there is no stopper outside, there is no stopper in the tin bottle, and so the vapors which are coming outside the tin bottle balances the temperature which is inside the bottle. So both the ways, here the air is also hot outside the bottle because this vapors are coming out, and the water which is inside the tin bottle is also hot. So equilibrium is created in this situation, and there is an imbalance in this situation, and the reason is why this bottle gets shrinked. You can do this activity at your home also. Now we are having some more examples given in the book of the atmospheric pressure. In the first example, you can see that the boy is sucking the water, or you can say a soft drink, example cold drink, Pepsi, fruity, anything. What is happening in this, that whenever we put the straw in the drink, and when we suck, the air get filled inside our lungs, and this straw becomes empty, or vacuum is being created in the straw, and that is why low pressure is created outside, and then the liquid start rising in the straw. You can see here in the example, when a drink is sucked with a straw, the air of the straw goes into the lungs, and thus the pressure in the straw decreases. The atmospheric pressure acting on the drink exerts force on the drink to move into the straw than into the mouth. So pressure acting outside is getting more than the pressure inside the straw, and that is why the drink start moving upwards. There are many more examples given in the book. Bulging of balloon, filling of the fountain pen, all these concept is based on this example which is given in the book of the straw. The next one is the example. Next example which is given is the syringe, that is the injection. The same process is also taking place in that situation also. And many more example is given in the book. About 10 examples given in the book, which is all about the same concept, which you have to read. If you have doubt, you can ask. Then we have the another example which is different, is the nose bleeding, and this nose bleeding is based on the concept of blood pressure, which I have already told you, that because blood is liquid, so it is also creating a pressure in the body. Nose bleeding often occurs at high altitude, and we have already studied that as we move high in the mountains, the atmospheric pressure decreases. Because the atmospheric pressure decreases, the nose start bleeding. The reason is that atmospheric pressure is low at high altitudes, but the pressure inside the human body is not changed. The pressure inside the body or the blood is more than the pressure outside the body, because as we move high in the altitudes, the atmospheric pressure decreases and pressure inside the body is more than the pressure outside the body, and that is why our nose start bleeding. So this is the reason why a nose often start getting bleeded because of this reason, or this concept of atmospheric pressure.